Guys, my name is Mohammad Izhaan Khan, and currently I am pursuing my bachelor's degree in civil and environmental engineering from IIT Patna. So today we continue our topic on continuity and differentiability. We were solving the exemplar for the same. So let's put the questions again. I think till question number 39 we had done in the last class, and no, today we have to start from question number 39, it seems. So let's move on to the first question for the day, 39. So the question says that we have to differentiate basically tan inverse sec x plus tan x. Range is minus pi by 2, say pi by 3. Alright. So I told you in the previous class that whenever you see such type of question, you have to basically know that there must be some form like this, something, and then this something will come out, and then we have to differentiate it. All right, but when does it happen? Can you recall this concept that whenever this whatever is inside, whatever it is making of this comes in this region, only then can you do this. All right. So in the inverse trigonometry, the domain is very important. It is not like you can do it same for every domain. So that is what you have to understand. And see, everywhere they'll give you this domain, not this. Basically, what happens is I'll show you an example. This is the graph for sine. So the domain for the inverse is minus pi by 2 say pi by 2, which covers from minus 1 to plus 1, all the values. All right. For this is sine. For cos, it is 0 say pi by 2. It covers all the values. This is for cos. For tan, it is minus pi by 2 say pi by 2. And like that, it goes on. So this is what you have to understand. All right. Now moving back to the question, we had with ourselves tan inverse sec x plus tan of x. So how can we solve this? First, we have to try and simplify it. If we fail to do so, then we'll just differentiate the tan inverse part and put the values. So what can I do with this? 1 upon cos sine of x plus sine x upon cosine of x. Alright, now we had seen we can write 1 as what? Sine square x by 2 plus cos square x by 2. Alright, how can we write sine x? Sine x we can write as 2 sine x by 2 cosine x by 2. Alright, we can write it like that. And furthermore, we have done with furthermore with the cos x part. Cos x I can write it as cos square x by 2 minus sine square x by 2. Alright, so let's move on. I'll just write it over here so that it is tan inverse 1 plus sine x. If I can write it as sine square x by 2 plus cos square x by 2 plus 2 sine x by 2 cos x by 2. This is the whole thing now, 1 plus sine x. And I can write it as sine x by 2 plus cos x by 2 the whole square. And it is divided by cos square x by 2 minus sine square x by 2. That means cos x by 2 minus sine x by 2 multiplied with cos x by 2 plus sine x by 2. Alright, tan inverse if I divide the whole term with a cos x by 2, alright, so what will we get? I'll get a 1 plus tan x by 2 and 1 minus tan x by 2. If you can recall the formula for, I can write this as pi by 4, right? Tan pi by 4 plus x, tan pi by 4 plus tan x, 1 minus tan pi by 4 into tan x. So we can write it as tan inverse tan pi by 4 plus x by 2. Alright, and after this we'll get pi by 4 plus x by 2. We have to differentiate this term with respect to x. Then what will be the answer for it? For this, it will be 1 by 2. Moving forward with the next question, we have with ourselves question number 40th. So in this question, we have been given tan inverse a cosine of x minus b sine of x whole divided by b cosine of x plus a sine x. Alright, and here also we have been given two minus pi by 2. See, if you don't understand this part, that why is it given, wait till you study inverse trigo. Alright, don't confuse yourselves. It is just for clearing your doubt. After you study inverse trigonometric functions, then you look for this in the question, that if it is given or not. So in order to prevent the confusion afterwards, they have given it beforehand. But just ignore it for now. Okay, I'll tell you when it is a different thing. Just ignore it for now. And another thing, you have been given that a by b tan x is greater than minus 1. I don't know what this is for. Okay, now I don't know what this is for. We'll solve the question. We'll see that if it is coming in use, it will definitely come in use. That is why it has been given. But for now, I can say that I don't know what this is for. Alright, so starting the question. So I have with myself y equal to tan inverse a cos x minus b sin x, b cos x plus a sin x. So again, if I divide the whole thing via cos, alright, via cos and via b. Yeah. So dividing everything by b cos x. Yeah. If I divide everything by b cos x, I'll be left over here with a by b minus divided by b cos x minus tan x. Alright. I divided everything by b cos x. 1 plus a by b tan of x. Alright. Simple enough. So now what can I do? Recall this formula. See, how can I put this? Can you do this tan inverse x minus tan inverse y? We can write it as tan inverse x minus y 1 plus xy. Do you remember this? Now I'll just go backwards from here to here. See, it is in the tan inverse x minus y 1 plus xy form. I'll just write it like this now. Alright, let's see what we are left with. So if I write it like that, I would have got a tan inverse a by b minus tan inverse tan of x. Alright, so I'll be left with a tan inverse a by b minus of x. Now my y has been changed to tan inverse a by b minus x. So if I differentiate it with respect to x, This part will come out to be 0 because these both are constants, and this part will give us a -1, which will be the answer. Moving forward, so in question number 41st, I've been given a secant inverse. See, these are basically trigonometric formulas. I can see it. Okay, so if you practice enough questions, you'll manage to get there. So don't get confused when you see these type of forms. See the solutions for these type of questions once, and see what is the procedure. Basically, what am I thinking? All right. So there's a secant inverse, and there is some algebraic form over here. But I know that I if I try to solve it, I can just differentiate it and put this whole value inside, and then complicate the whole stuff. But it will give me the correct answer. It will be complicated, but it will be correct. But I know that in the exam, nobody will want you to be rigorous in your work. They'll want you to be clever. So I know that these they want us to put some value over here. Okay, so that this 4x cube minus 3x comes out to be something. So let's see. So I'll just ask you this question. What is the formula for cos 3 theta? It is nothing but 4 cos cube theta minus 3 cos theta. See, the same thing has been written over here. So in place of x, if I put cos theta, alright, what will I get? I'll get a secant inverse 1 upon 4 cos cube theta minus 3 cos theta. And this is nothing but 1 upon cos 3 theta. Simple. And this is sec inverse, this is cos. So if I try to write it in sec, it will be sec 3 theta. Alright. So I'll be left over here with what? 3 theta. Now, what was, let's see now. So my y is now 3 theta. My x was equals to cos theta. So theta will be equal to cos inverse x. So y will be equal to 3 times of cos inverse. Simple. Now I just have to differentiate this cos inverse part. So this is pretty simple, right? This is just a formula. So minus 1 upon under root 1 minus x square. So minus 3 1 minus x square will be your answer. It was a simple question, right? So moving forward, we'll see the next question. Question number 42nd. So I have with me tan inverse 3a square x minus x cube whole divided by a cube minus 3a x square. So this is also a formula for tan, and I would like to give you a very important tip regarding the exam. So basically what happens is most of us do this mistake of thinking that the question in the exams, like whatever we solve right now, whatever we'll make, like some of you will start to think that whenever this form comes, I have to remember that I have to do this. Alright, so this is the wrong approach. What will happen is the question will come much more complex than this. You have to make it to this form and then move forwards. Got it? There will be some other form, and then you'll apply some algebraic logics, and you'll get to this point. After getting to this point, then it will click to you, Achha, you can do this. So if you remember that there is some algorithm that if you see 3a square x, then you have to put this. All this is wrong. All right. If you do this, you will not be able to solve the question definitely. So I suggest that you do these type of questions as much as you can, so that it is like you can, if you see a 3as is square x or something like that, if you see something that can become like this, okay, then it should click to your mind. Okay, then that is the tan formula, and that is how I must proceed. So again I'm telling you that don't go by making some algorithms by yourself. So y is equals to this, and if I try to simplify it, I can write it as, I'll divide the whole thing by an a cube. So let's see what that gives me. Alright, so what can I do? I can say that this x upon a, this x upon a is my tan theta. Okay, and y is equals to tan inverse 3 tan theta minus tan cube theta 1 minus 3 tan square theta. And this is the formula for what? Tell me quickly. So my y is equals to tan theta and theta is equals to tan inverse x upon a. So my y is equals to 3 times tan inverse x upon a. Y is equals to 3 times tan inverse x upon a. Alright. Now, if I differentiate it with respect to x, what will I get? 3 times 1 upon 1 plus x upon a का whole square. Simple. So 3 and this is x upon a का whole square. So a square plus x square. This will be your answer. Moving forward, I have another question. Question number 43rd, which is tan inverse under root 1 plus x square plus under root 1 minus x square under root 1 plus x square minus under root 1 minus x square. Alright. So what can I do? Think. I'll try to put x square is equals to cos 2 theta. Can you tell me why? If I do that, see, under root 1 plus cos 2 theta has been given to me, right? So 1 plus cos 2 theta can be written as cos square theta minus sin square theta. Not just this, I can write it as 2 cos square theta minus 1. So in under root 1 plus 2 cos square theta minus 1, I'll be left out with under root 2 cos theta. Alright, and similarly for under root 1 minus cos 2 theta, this will give me under root 2 and sin theta. Got this? 1, 2. That is why I've chosen this. So tan inverse under root 1 plus cos 2 theta plus under root 1 minus cos 2 theta under root 1 plus cos 2 theta minus under root 1 minus cos 2 theta. Simple. And I can write it as tan inverse under root 2 cos theta plus under root 2 sin theta and under root 2 cos theta minus under root 2 sin theta. Okay. And tan inverse, if I divide the whole thing by under root 2 cos theta, then I'll be left out with simple. And then I'll write it as so pi by 4 plus theta will be my y and dy by dx. Oh, not still. Y is equals to pi by 4 plus theta. But what is theta equal to? Cos inverse x square. See, y is equals to pi by 4 plus theta. And I had put x square is equals to cos theta. So theta will be equal to cos inverse x square. Okay. So y will be equal to pi by 4 plus cos inverse x square. And on differentiating it with respect to x, I'll be left out with where is this question? So it will be minus 1 upon under root 1 minus x4 into 2x. So this will be your answer. Minus 2x times minus 2x upon under root 1 minus x4. So moving forward, find dy by dx of each of the function expressed in the parametric form from 44 to 48. Okay, still we have many questions left. So x is equals to t plus 1 upon t and y is equals to t minus 1 upon t. So first of all, we go dx upon dt. It will give me 1 t raised to the power of minus 1. So minus 1 upon t square, and dy by dt will be 1 plus 1 upon t square. Okay. Dy by dt whole divided by dx upon dt. It is nothing but dy by dx. So it is dy by dt is 1 plus 1 upon t square, 1 minus 1 upon t square. So I can write it as t square plus 1, t square minus 1. This will be your answer. Now moving on to the next question. Question number 45. It has been given to me that x is equals to e raised to the power of theta plus into theta plus 1 upon theta, and y is equals to e raised to the power of minus theta, theta minus 1 upon theta. Okay. So first of all, I would like to differentiate this dx upon d theta. So I'm differentiating this part. So it will be 1 minus 1 upon theta square. Okay. Plus, I'll differentiate this part. So e theta, theta plus 1 upon theta. So adding the whole thing up, e raised to the power of theta will come out in common. Theta plus 1 upon theta. So this is your whole part for dx upon d theta. Okay. And now for dy by dx. So now for dy upon d theta, first of all, I'll keep this as constant, and differentiating inside, I'll be left out with plus 1 upon theta square, and then I'll keep this part as constant, theta minus 1 upon theta, and minus e raised to the power of minus theta. So dy by d theta will come out to be e minus theta 1 plus 1 upon theta ka square minus theta plus 1 upon theta. This is your dy by d theta. And So I'll just differentiate. I'll just divide the both of them. So dy by dx is equals to dy by d theta whole divided by dx upon d theta. So e raised to the power of minus theta square plus 1 minus theta cube plus theta by theta square divided by e raised to the power of theta square minus 1 plus theta cube plus theta whole upon theta square. ठीक है. So e minus 2 theta minus theta cube plus theta square plus theta plus 1 whole divided by theta cube plus theta square plus theta minus 1. So this will be your answer. So moving on to question number 46. It has been given to me that x is equals to minus 3. Wait. X has been given to me as 3 cos theta minus 2 cos cube theta. 3 cos minus 2 cos cube theta. And y has been given to me as 3 sin theta minus 2 sin cube theta. Alright. Okay. So first of all, let's find dx upon d theta. So differentiating it, I'll be left out with minus 3 sin theta. Okay, minus 6 sin square theta minus 3 cos square theta, right? Minus 6 cos square theta and dy dx of cos theta is minus sin theta. So it will come out to be a plus 6 cos square theta sin theta. Okay. Now let's find dy by d theta. So it will be 3 cos theta minus 6 sin square theta cos theta. Okay. So finding dy by dx, I'll get 3 cos theta minus 6 cos theta sin square theta whole divided by minus 3 sin theta plus 6 cos square theta and sin theta. So simplify this term as much as possible and that will be your answer. Okay. So moving forward, I have with me question number 47. Yeah. So question number 47 has given to me that sin x is equals to 2t upon 1 plus t square. It is a good question, alright? And tan y is equals to 2t upon 1 minus t square. Okay. So how can we solve this? Some of you must be thinking that we can just differentiate sin x. So you'll get dx upon dt, but you'll also get a cos x term extra. So that will pose a problem. Whenever you solve in a parametric form, you have to make sure that, like, if you try to find dx upon dt or dx upon d theta, then there must not come any other term in x. Okay, then that is the parametric form, right? That कोई भी अलग term x में नहीं आ रही हो. You should only get a t or theta terms. So if you go by that approach, differentiating like we have been doing previously, then you'll get stuck. So in order to do this, let's see what we can think of. So 2t upon 1 plus t square, it is similar as 2 tan theta upon 1 plus tan square theta. So I can put this formula t equal to tan z for now. So sin x is equals to 2 tan z upon 1 plus tan square z. Alright. This can be written as sine 2z. Alright. So x is equals to 2z. This is your first observation. And now moving forward, tan y equal to 2 tan z upon 1 minus tan squared z, tan 2z. So y is equals to 2z. Y is also equal to 2z. That means x is equals to y. This is your critical observation. So in that case, if you find dy by dx, what will it come out to be? 1. Simple answer. Okay. So moving forward, question number 48. X is equals to 1 plus log t whole divided by t square, and y is equals to 3 plus 2 log t whole divided by t. Okay, what can we do in this situation? Hmm. Since I cannot think of anything else, I'll just differentiate it like this. Okay. So on doing so, what will I get? T square 1 plus log t ka differentiation will be 1 upon t minus 1 plus log t times 2t whole divided by t square ka whole square. Alright. So this, if I simplify it, I'll be left out with what? T minus 2t minus 2t minus 2t log t and t4. So minus 1 minus 2 log of t divided by a t cube. So this is your dx upon dt. Now dy by dt, it is t, differentiation of 3 plus 2 log t will be 2 by t minus 3 plus 2 log t, and dy dt will give you what? R1 whole divided by a t square. Yeah, t square. So on simplifying it, 2 minus 3 minus 2 log of t whole divided by t square minus 1 minus 2 log t upon t square. So in order to find dy by dx, divide dy by dt by dx by dt. So it is minus 1 minus 2 log t whole divided by t square and minus 1 minus 2 log t whole divided by a t cube. So it is equals to t. Question number 49. It has been given to us that if x is equals to e cos 2t and y is equals to e sin 2t, then we have to prove that dy by dx is equals to minus y log x upon x log y. ठीक है, तो ठीक है, तो सबसे पहले तो log के फॉर्म में इसको ले आते हैं. सो cos 2t is equals to log x and sin 2t is equals to log y. ठीक है. Cos square 2t plus sin square 2t is equals to 1. इसकी वजह से log x का होल स्क्वायर प्लस log y का होल स्क्वायर इज इक्वल टू 1. ठीक है, ओके. तो अब यहाँ से डिफरेंशिएट कर देंगे, एक इक्वेशन मिल तो गई है. सो 2 log x इंटू 1 अपॉन एक्स प्लस 2 log y इंटू 1 अपॉन y इंटू dy बाई dx इंटू dy बाई dx इज इक्वल टू क्या हो जाएगा 0. ठीक है, 2 log x इंटू 1 अपॉन एक्स प्लस 2 log y इंटू 1 अपॉन y dy बाई dx. ठीक है, क्या था पीछे 2 log x इंटू 1 upon x plus 2 log y into 1 upon y into dy by dx equal to 0. So 2 log y upon y dy by dx is equals to minus 2 log x whole divided by x. Okay. So dy by dx is equals to minus y minus 2y log x minus 2y log x divided by 2 log y and then x. So 2 से 2 कट जाएगा and we'll be left out with minus y by x. यहाँ पे आएगा log x, यहाँ पे आएगा log y. So let's move on to the next question, question number 50. ठीक है, question number 50. तो if x is equals to a sin 2t, x is equals to a sin 2t 1 plus cos 2t and y is equals to b cos 2t 1 minus cos 2t, then we have to prove that dy by dx at x is equals to pi by 4 is equals to b by a. To prove, all right, so this is your a, this is your y, x and y. Okay. X is equals to a sin 2t 1 plus cos 2t. ठीक है, differentiating with respect to t, a sin 2t cos 2t का differentiation will be minus 2 sin 2t plus 1 plus cos 2t a cos 2t और 2. ठीक है, so finally dx by dt को कैसे लिख सकते हैं? dx by dt will be minus 2a sin square 2t plus 2a cos 2t ब्रैकेट में 1 plus cos 2t. हो गया dx by dt वाला टर्म. dy by dt is equal to b cos 2t into 2 sin 2t. ठीक है, प्लस 1 minus cos 2t minus 2 sin 2t. ओके, और ये हो जाएगा dy by dt पूरा. ठीक है, तो dy by dx 2b sin 2t cos 2t sin 2t cos 2t minus 1 minus cos 2t and sin 2t whole divided by minus 2a साइन स्क्वायर 2t माइनस कॉस 2t 1 प्लस कॉस 2t एट x इज इक्वल्स टू, यानी t इक्वल टू पाई बाय 4, तो यहाँ पे आ जाएगा माइनस बी अपॉन ए, ऊपर आ जाएगा पहले तो साइन पाई बाय 2 कॉस पाई बाय 2, उसकी कॉस पाई बाय 2 की वजह से हो जाएगा 0, माइनस 1 माइनस कॉस पाई बाय 2, ठीक है, कॉस पाई बाय 2 हो जाएगा 0, साइन पाई बाय 2 हो जाएगा 1, तो यहाँ पे आ जाएगा -1, नीचे साइन स्क्वायर पाई बाय 2 हो जाएगा 1, कॉस पाई बाय 2 की वजह से हो जाएगा 0, सो दिस विल बी इक्वल टू बी अपॉन ए, जो हमें प्रूव करना था। क्वेश्चन नंबर 51st, if x is equals to 3 sine of t minus sine of 3t and y is equals to 3 cosine of t minus cosine of 3t, then find dy by dx at t equal to pi by 3. तो dy by dt is equals to what? 3 sin 3t minus 3 sin t, ठीक है, and dx upon dt is equals to 3 cosine t minus 3 cos 3t. Okay, if dividing the both of these, dy by dx, I will be left out with sine of 3t minus sine of t whole divided by cosine t minus cosine 3t, and putting the value of t is equals to pi by 3. Let's see, so pi by 3 sine pi minus sine pi by 3 and cos pi minus cos pi. Okay, तो यहाँ पे आ जाएगा साइन पाई माइनस साइन पाई बाय 3 और इसी का उल्टा cos पाई बाय 3 माइनस cos पाई, तो यहाँ पे आ जाएगा 0 माइनस अंडर रूट 3 बाय 2 1 अपॉन 2 माइनस माइनस 1, तो ये कितना होगा माइनस अंडर रूट 3 बाय 2, यहाँ पे आ जाएगा हाफ प्लस 1 3 बाय 2, तो माइनस 1 अपॉन अंडर रूट 3, आंसर। क्वेश्चन नंबर 52nd, डिफरेंशिएट x अपॉन साइन x विद रिस्पेक्ट टू साइन x। अच्छा, तो हमारे पास y है x अपॉन साइन x और हम मान लेते हैं हमारे पास z है साइन x, तो हमें बेसिकली उन्हें बताना है सोल्यूशन फॉर dy बाय dz, ठीक है। तो सबसे पहले dy बाय dx कर लेते हैं, dy बाय dx विल बी इक्वल टू व्हाट, बेस में तो आ जाएगा साइन x का होल स्क्वायर, ऊपर आ जाएगा एक साइन x, dy बाय dx विल बी 1 माइनस एक x इंटू साइन x का डिफरेंशिएशन इज cos x, तो ये हो जाएगा होल फॉर्म उसका, dy बाय dx इज इक्वल्स टू साइन x माइनस x cos x होल अपॉन साइन स्क्वायर x, ठीक है, दिस इज dy बाय dx। अब dz बाय dx करके देख लेते हैं, इज इक्वल्स टू cos x एंड dy बाय dz विल बी आवर आंसर, है ना। तो dy बाय dz कर लेते हैं, dy बाय dz इज इक्वल्स टू साइन x माइनस x cos x होल अपॉन साइन स्क्वायर x पूरा नीचे cos x। तो यहाँ आ जाएगा साइन x अपॉन साइन स्क्वायर x cos x माइनस x cos x अपॉन साइन स्क्वायर x cos x, यहाँ आ जाएगा tan x अपॉन साइन स्क्वायर x minus x upon sin square x dy by dz tan x minus x upon sin square x. This will be your answer. Question number 33. Differentiate tan inverse this with respect to tan inverse x. ठीक है. 53rd. दिया हुआ है tan इनवर्स अंडर रूट 1 प्लस एक्स स्क्वायर माइनस 1 अपॉन एक्स, और इसको डिफरेंशिएट करना है विद रिस्पेक्ट टू tan इनवर्स एक्स. तो फिर से वैसे ही करेंगे. ये हो गया y और z हो गया tan इनवर्स x, और हमें बस बताना है उसको dy बाय dz. ठीक है. तो कैसे सॉल्व करेंगे इसको? सबसे पहले मैं x को ले लेता हूँ tan थीटा. तो थीटा क्या हो गया? tan इनवर्स x, यानी थीटा हो गया z इज इक्वल टू tan इनवर्स x. तो मेरा y बन जाएगा tan इनवर्स अंडर रूट 1 प्लस tan स्क्वायर थीटा माइनस 1 अपॉन tan थीटा. ठीक है. tan इनवर्स, अब अंडर रूट 1 प्लस tan स्क्वायर थीटा है मेरे पास, तो उसको मैं लिख सकता हूँ sec स्क्वायर थीटा. तो वो हो जाएगा 1 प्लस tan स्क्वायर थीटा is sec स्क्वायर थीटा. यहाँ पे हो जाएगा sec थीटा माइनस 1 अपॉन tan थीटा. sec थीटा माइनस 1 अपॉन tan थीटा. ओके. तो यहाँ आ जाएगा tan इनवर्स 1 माइनस cos थीटा अपॉन sin थीटा. tan इनवर्स 2 sin स्क्वायर थीटा बाय 2 sin थीटा बाय 2 cos थीटा बाय 2. tan इनवर्स tan थीटा बाय 2, यहाँ पे हो जाएगा y इज इक्वल्स टू थीटा बाय 2. ओके. तो dy बाय d थीटा इज इक्वल्स टू हाफ ऑफ 1, हाफ इंटू 1. ठीक है. और dz बाय d थीटा इज इक्वल्स टू, बताया था ना z इज इक्वल्स टू थीटा हो रहा था, तो d थीटा d बाय d थीटा ऑफ थीटा विल बी ऑल्सो इक्वल टू 1. सो dy बाय dz will be equal to 1 upon 2. Okay, so moving forward, question number 54. Sin xy equal to x square minus y. ठीक है. तो अगर हम लोग ऐसे ही डिफरेंशिएट इसको कर दें, cos एक्स वाई, एक बार x कांस्टेंट रहेगा तो फिर x dy बाय dx प्लस y प्लस यहाँ पे बेस में आ जाएगा y स्क्वायर y माइनस x कांस्टेंट माइनस x dy बाय dx, और दिस इज इक्वल्स टू 2x माइनस dy बाय dx. ये पूरा टर्म तैयार हो गया है. तो अपॉन सॉल्विंग क्या मिलेगा इसमें? cos xy x dy by dx plus y plus y minus x dy by dx अपॉन y स्क्वायर. इतना पार्ट है, इसको हम लोग लिख सकते हैं cos xy xy स्क्वायर dy by dx प्लस y क्यूब प्लस y माइनस x dy by dx. ठीक है. dy by dx दोनों तरफ से कॉमन ले लेंगे तो we'll be left with 2xy square minus y cube cos xy minus y all divided by xy square cos xy minus x plus y square. ये हो गया हम लोग का आंसर. So next question number 55. Sec x plus y is equals to xy. ठीक है, तो sec x plus y tan x plus y और 1 plus dy by dx, इतना पार्ट इज इक्वल्स टू x dy by dx प्लस y. ठीक है, dy by dx sec x plus y tan x plus y minus x, this is equals to y minus sec x plus y tan x plus y. ठीक है, तो dy by dx यहाँ से हम लोग को मिल चुका है. dy by dx is equal to y minus sec x plus y tan x plus y divided by sec x plus y tan x plus y minus x. ठीक है, तो मूविंग फॉरवर्ड क्वेश्चन नंबर 56. tan inverse x square plus y square is equals to a. ठीक है, तो x square plus y square तो हो जाएगा tan a. यहाँ पे 2x plus 2y into y dash is equals to 0. तो 2y y dash is equals to minus 2x था, 2 कट जाएगा, तो y dash is equals to minus x upon y. आंसर. Next question. Y raised to the power of x is equals to ey upon ex. Then we have to prove this. Okay. लॉग कटर मारा है, ठीक है, तो लॉग लेना पड़ेगा. अच्छा, ओके, तो इसको लिख सकते हैं x log y is equals to y minus x. ठीक है, एंड log y is equals to हो जाएगा y by x minus y. ओके, ठीक है ना. तो या तो इसको वैसे ही रहने दें, x log y, तो डिफरेंशिएट करने में इजीली काम हो जाएगा. इसको अगर डिफरेंशिएट करूं x को कांस्टेंट रख के, dy by dx माइनस 1. ठीक है, तो dy by dx को पूरा अगर कर दें तो log y प्लस 1 होल ओवर 1 माइनस x अपॉन y. तो y log of y प्लस 1 होल ओवर बाय y माइनस y अपॉन 1 प्लस log y. तो 1 प्लस log y का होल स्क्वायर डिवाइडेड बाय log y. यही हम लोग को प्रूव करना था. तो अब क्वेश्चन नंबर 61.
हाय ईजान.
हेलो, ये सर.
ईजान आज यहीं तक रखें.
ठीक है सर, ओके,
ओके.
थैंक यू सर.